Um, Welcome to today's lecture. I want to believe that you went through the previous work we did on stoichiometry. This is part 4 on stoichiometry, and this is the concluding lecture on stoichiometry. Part 3 ended with an exercise that you're supposed to do, and we want to look at the exercise together in order to bring us to the conclusion of stoichiometry. So let's quickly look at the question. It says 50 gram of sodium trioxocarbonate 4 reacts with 50 gram of dilute HCl acid. Calculate, Roman figure 1, the mass of the excess reactant left. Roman figure 2, the percentage of the excess reactant used. Roman figure 3, the volume of CO2 gas produced at STP. And then we're given the equation of reaction Na2CO3 plus 2HCl, which are the reactants to produce NaCl plus H2O plus CO2. We're also given the atomic masses. Sodium is 23, carbon is 12, oxygen is 16, hydrogen is 1, chlorine Cl is 35.5, and the molar gas volume is 22. Please, I beg your pardon, this is 22.4 gm3. Now, like we did in our previous lecture, we're given two masses, that is 50 gram for one of the reactants and another 50 gram for the second reactant. We have two reactants there. The two reactants are sodium trioxocarbonate 4 and hydrochloric acid, dilute hydrochloric acid. Like I said before, we cannot tell if the masses are given in appropriate quantity, and as a result of that, we cannot tell which is the limiting reactant or which is the excess reactant. So we have to determine that on our own. How do we do that? You write the equation of reaction as it is given to you, and you will also ascertain that the equation is balanced. It must be balanced. Okay, looking at it, you will have two atoms of sodium here. We have one atom of carbon, one atom of carbon. We have three atoms of oxygen, and then one here and two here. That makes it three atoms of oxygen. We have one that is multiplied by 2. That's 2 atoms of hydrogen. 2 atoms of hydrogen, 2 times the chlorine. That's 2 atoms of chlorine, 2 atoms of chlorine. Therefore, the equation of reaction is balanced. And so we now say from equation, that is, from this equation, that's where you start the whole problem from. Okay, if you look at the stoichiometric coefficient of sodium trioxocarbonate 4, that's 1, that of HCl is 2. So from the equation, number of mole of sodium trioxocarbonate 4 to number of mole of HCl is 1 to 2. Remember, we said in our previous class that ratio is another word for division. So 1 to ratio 2 is the same as 1 over 2. And if you resolve that, you're going to get 0.5 over 1. Now, from the reaction, what is the reaction? The reaction is what we're given. We're given 50 grams for sodium trioxocarbonate 4 and 50 grams for HCl. So in order to convert mass to mole, remember, we said that you will do mole equal to known mass over molar mass. If you look at this place, I gave the formula in case you forget. Mole is known mass over what? Over molar mass. So that's exactly what we'll apply here to solve this problem. So we're given 50 for sodium trioxocarbonate 4 and 50 for HCl. So we need the molar mass of sodium trioxocarbonate 4. Sodium trioxocarbonate 4. Using the atomic masses, we have 2 atoms of sodium, that's 2 times 23, which is the atomic mass for sodium, 1 atom of carbon, 1 times 12, 12, which is the atomic mass for carbon, and then oxygen, we have 3 atoms here, 3 times 16, 16 the atomic mass for oxygen. So if you resolve carefully, you will end up at 106 grams per mole. You pick up HCl, 1 atom of hydrogen, that will be 1 times 1, which is the atomic mass of hydrogen, and then 1 times 35.5, which is the atomic mass for chlorine, and then if you resolve carefully, you will get 36.5 grams per mole. So then we need to convert the mass given to mole so that we can adequately compare our result with the result we got when we resolve that of the equation. So let's see that now. 50 grams of sodium trioxocarbonate 4 divided by the molar mass, which is 106, will give us 0.472. 50 grams of hydrochloric acid divided by the molar mass, 36.5, will give us 1.37. Don't forget, the ratio means division. So we take the division now. That will give us 0.472 over 1.37. If we resolve that, we're going to get 0.345 to ratio 1. So if you compare our result, that is the result for the reaction, with the result for the equation is saying that 0.5 mole is needed for Na2CO3 and 1 is needed for HCl by the time you finish resolving. And here, by the time we finished resolving, the reaction is saying we have 0.345 for sodium trioxocarbonate 4 and 1 for HCl. As a result, if you look at it properly, comparing the values, you will see that for sodium trioxocarbonate 4, we have 0.345. For the reaction, equation is saying we need 0.5. Therefore, since we don't have up to 0.5, it means that sodium trioxocarbonate 4 is the limiting reactant. In other words, that is the reactant that determines how far the chemical reaction can occur. That is the reactant that is used up, and once it is used up, the whole reaction comes to an end. Hence, the other reactant becomes the excess reactant. Having determined the limiting reactant and the excess reactant, we can now fully go to solve the problem. What is problem 1? Problem 1 says we should calculate the mass of the excess reactant left. The mass of the excess reactant left. For us to calculate the mass of the excess reactant left, we must get the mass of the limiting reactant. We must calculate the mass of the excess reactant used. We must calculate mass of excess reactant used. So we write the limiting reactant Na2CO3 and the excess reactant HCl. Using the equation of reaction again, you will see we have the stoichiometric coefficient of sodium trioxocarbonate 4 is 1, that of HCl is 2. So we can come here and say 1 mole for Na2CO3 and 2 moles of HCl from the equation. Now we are told to calculate the mass of the excess reactant left. So it is mass we are required to calculate. So we use our formula. Mole is known mass, that is given mass, mass over molar mass. So the given mass or known mass or mass is mole times molar mass. So we have 1 mole multiplying by the molar mass of Na2CO3, that is 106. If you multiply that, you get 106 gram. If you do the same thing here, the molar mass of HCl is 36.5. If you multiply by 2, you are going to get 73. So 106 grams will need or will react with 73 gram. So 50 gram will react with X. Remember I said the side facing what you're looking for will be used for division when you cross multiply. So when we are cross multiplying, we do 50 times 73 divided by 106. Once you do that, you're going to get 34.4 gram. Hence, mass of the excess reactant used is 34.4 gram. So, mass of excess reactant left will now be 50 gram, which is the mass of the excess reactant given, minus that which is used up. And that will give us 15.6 grams. So 15.6 gram is the mass of the excess reactant left. So let's look at question number 2. Question number 2 says the percentage of the excess reactant used. The percentage of the excess reactant used. So what's the percentage? The percentage of the excess reactant used. The percentage of excess reactant is equal to, means the percentage of excess reactant used is mass of excess reactant used over mass of excess reactant given times 100%. So what's the mass of excess reactant used? 34.4. What is mass of the excess reactant given? 50 gram times 100%. When you resolve that, you will get 68.8%. So let's look at the last question. The last question says that the volume, we should calculate the volume of CO2 gas produced at STP. Don't forget we're given the molar gas volume as 22.4 dm cube. So again, we start with the limiting reactant, which is Na2CO3. This is CO3, I beg you, this is C, then O3. I omitted C, so I had to just compress C there. And then CO2, which is the gas that is produced. So looking at the equation of reaction again, you will see that the stoichiometric coefficient of Na2CO3 is 1, and that of CO2 is also 1. And therefore we say 1 mole of Na2CO3 will produce 1 mole of CO2 gas. 1 mole of Na2CO3 will produce 22.4 dm cube of CO2 gas. In other words, we have converted mole to volume. Don't forget the relationship between mole and volume. When you come to gases at STP, 1 mole of a gas occupies 22.4 dm cube. So you just multiply the mole here by the gas molar volume or molar gas volume, which is 22.4 dm cube, and that will give us 22.4 dm cube. Now, we're not given mole for Na2CO3, we're given mass. So we repeat the same process again. We have to convert the mass to mole by dividing the mass given by the molar mass, and that will give us 0.472 mole. So we can just put the mole there. Okay, so if we resolve this, that will give us this. So 0.742 mole requires x dm cube of CO2. We actually don't need this because this is the same as this. Don't forget the side facing what you're looking for will be used for division when you cross multiply. So we're cross multiplying now x times 1. That means 1 will be used for division, and I will do 0.472 times 22.4 divided by 1, and that will give us 10.6 dm cube of CO2. So this brings us to the conclusion of stoichiometry. I want to believe that this lecture would have impacted you.